Hi, I'm ReRe and welcome to the YarnOverHook podcast, Exploration Crochet. Today, we're diving into two of my great loves, crochet and, brace yourself, math. Yes, math. Stay with me. If you're not a math nerd, please don't touch that skip button. I know some of you out there just broke out in a cold sweat and had flashbacks to pop quizzes and graphing calculators, but trust me, this is fun math. This is cozy math. This is math you can literally wrap around your shoulders on a chilly night. And while crochet is known as a relaxing craft, because it is, under the hood it's got math running everywhere. Geometry, spirals, symmetry, algorithms. It's math with yarn. So in this episode, we're going to unravel, see what I did there, the ways math and crochet are secretly besties. By the end, you'll be able to say, see, I do use math in real life. All right, let's get started. Okay, I'm so glad my mentioning the M word didn't scare you away. So since you're still here, let's start with something gentle. Something you've been playing around with since you were very little. Geometry. You know, little shapes you used to draw, cut out, build things with. Squares, circles, rectangles, triangles. Now, think back to your very first crochet project. Maybe it was a scarf. Long, flat, rectangular-ish. Or maybe you jumped right in with amigurumi and made something ball-like. What you were doing was playing with shapes. Geometry. Rows equal rectangles, circles in the round equal polygons. Add increases and decreases and you have curves, cones, bowls. And here's the sneaky math. Crocheting a flat circle has a formula. You have to increase stitches at just the right intervals. Too few increases, congratulations, you've made a bowl. Too many, and ruffles. If you want to dive more into the mathematics of circles, check out the great video by Crafters Autonomous, The Math Behind a Crochet Circle and Why It Matters. I'll drop the link in the description. But now, let's go back to ruffles. They are actually a perfect example of math rules in action. By intentionally adding extra stitches, you create rippling, wavy borders that are mathematically fabulous. Mathematicians call it negative curvature. But add it to a bucket hat, and that math becomes a fashion statement. I hope to do a whole separate podcast on ruffles and hyperbolic crochet. Hyperbolic geometry sounds intimidating, but it's just math for curved spaces. Crochet is one of the practical ways to model hyperbolic planes. Mathematicians use crocheted hyperbolic models to study curvature and space. Artists have used it scaled up to create massive crochet reef installations. If you like, you can check out some hyperbolic objects crocheted by the students from the math department at the University of Wisconsin-Madison. I'll be sure to leave the link below. From ruffles, let's talk about spirals. Now this was my first crochet project. Groups of double crochet and a single stitch along a chain, creating in essence a corkscrew. And finally, a hair tie. With spirals, you can have the Fibonacci sequence. That magical little set of numbers nature can't seem to get enough of, each number being the sum of the two before it. 1, 1, 2, 3, 5, 8, 13. It's like nature's favorite playlist on repeat. Sunflowers, Fibonacci. Pine cones, Fibonacci. That seashell you collected at the beach, Fibonacci. Your houseplant when it's feeling cute, yep, probably Fibonacci. Crochet borrows the same beauty. When designing spiral motifs, crocheters often increase following Fibonacci numbers. The result? Spirals that look like they belong on a coral reef, or on a math teacher's desk. And here's where it gets even fancier. The Fibonacci sequence connects to the golden ratio, also known as the divine proportion. That's the secret sauce behind why certain rectangles just look right. Artists, architects, even people who designed the iPhone have used it. So when you crochet a spiral or design with these numbers, you're lining up with the same principles Da Vinci used for the Mona Lisa, which happens to feature the golden ratio, reveals several golden triangles, as well as the golden spiral. So, is your granny square spiral worthy of the Louvre? Probably. Will they let you hang it there? Probably not. But you can dream. Now, let's reflect on symmetry. Crochet is obsessed with it. Think granny squares, perfect little boxes of harmony, or a doily, radiating outward with flawless radial symmetry. Honestly, a well-designed doily is like a crochet mandala, hypnotic, balanced, beautiful. Symmetry gives projects a sense of completion. It's why your brain goes, ah, when you finish a square. Humans love balance. It's like comfort food for the eyes and mind. But crochet can also channel something wilder. Fractals. Fractals are patterns that repeat on smaller and smaller scale. Think of the Sierpinski triangle. It's a big triangle made up of little triangles made up of teeny tiny triangles. If you'd like to see this, check out virtualmathmuseum.org. They show how the Sierpinski triangle can be thought of as a single strand of yarn, looping endlessly. I'll put the link in the description. Crochet can mimic fractals by using repeating motifs. Shawls, blankets, wall hangings, any of these things with a repeating pattern is basically a fractal in yarn form. And here's the bonus. Fractals can help explain why crochet feels so meditative. Our brains are wired to love repetition and patterns. Crochet gives us that rhythm and symmetry we can touch, hold, and wear. Crochet is like listening to your favorite song on repeat. It hits the same soothing rhythm over and over. And by the end of a project, you're wrapped up in something that feels just right. Okay, you've stuck with me so far, and I really appreciate it. So now let's get real nerdy. Every crochet pattern is, at its core, an algorithm. An algorithm is simply a set of rules that guide you step by step toward a predictable outcome. And that's exactly what a crochet pattern does. Chain 3, double crochet in the next stitch, repeat to end of row, 25 stitches. That's programming. Only instead of producing software, you can produce something soft you can wear. Stitch counts function like equations. Add a double crochet here, you'll need a chain there to keep the fabric balanced. Skip one, and suddenly the symmetry collapses, and the whole structure looks off. Then there are motifs. Granny squares, hexagons, corner-to-corner blocks. These are modular building units, just like the shapes in a tangram puzzle. In math terms, these elements you can transform, rotate, reflect, or translate, while still fitting neatly into a larger whole. Crochet is tessellation in yarn, repeating units that lock together into something greater than the sum of their parts. Lay out 42 granny squares and you've got a geometric canvas. Rearrange them and you explore new symmetries. Rotate them and you test transformation. It's the same mathematical curiosity that makes tiling patterns, mosaics, and puzzles so irresistible. Only this one happens to keep you warm. So if you've ever followed a crochet pattern, congratulations. You've been running algorithms, exploring transformations, and tessellating with yarn. Crochet patterns aren't just recipes for fiber art, they're living demonstrations of how mathematical precision can create beauty. It's kind of like doodling in 3D with rules of geometry. Repeat, rotate, reflect, connect, and suddenly, bam, you've got a sweater. So what's the great takeaway here? Crochet is math. You've been doing math all along. No worksheets, no chalkboards, just yarn. Every flat circle, every granny square, every ruffled edge. That's math dressed up as a craft. Geometry, Fibonacci spirals, hyperbolic curves, symmetry, fractals, algorithms, they're all baked right into the stitches you make. And here's the beautiful part. Ancient mathematicians gave us the word algorithm. They mapped out geometry and they explored the mysteries of curved space. They worked with ink and parchment. Now you're exploring those same ideas with hook and yarn. And mathematicians weren't the only ones. Islamic artisans tiled mosques with tessellations so precise they rival any modern geometry textbook. Lace makers in Renaissance Europe built fractals with thread. Navajo weavers encoded symmetry and balance into their rugs. Makers across centuries and cultures have always carried math in their hands. So when you crochet, you're not just following a pattern. You're part of a lineage, a conversation between mathematicians and artisans, stretching back thousands of years. Crochet, it's such a cozy hobby. And it's math made tangible. Math you can wear. Math that hugs you back. So, until next time, thanks for listening, and keep those hooks moving, your circles flat, and your ruffles ruffly. Happy stitching.